Alrighty, let's talk about exponents for a little bit. Let's first talk about what an exponent might look like, or a number with an exponent. We might have something like 3 with this little 2 in the upper right-hand corner. This 3 is called the base, and this 2 is referred to as the power or the exponent. Now, the exponent tells you how many times you're going to multiply the base. So, in expanded form, or expanded notation, that's going to look like this, 3 times 3. Notice it's not 3 times 2. This 2 is only telling you how many times you want to multiply the base. So in this case, you can see we've got 2 3s. We're going to multiply the 3 to itself twice. So 3 times 3 is going to give us 9. Now 9 is in a special form. It's not an expanded form. That's the answer to the problem. That would be in standard notation. The reason I'm mentioning all these terms is because on the homework, you're going to have some numbers in exponential notation. Then you're going to have to write numbers out in expanded notation. And then lastly, it will be in standard notation. So the answer to the problem would be the standard number. Okay. All right, so let me give you a couple of examples. So say we have 2 to the 3rd power. What that means is we're going to multiply this 2 3 times. So 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So the standard notation for this amount is 8. Let's say we have another cubed number, 5 to the 3rd power. 5 times 5 times 5. 5 times 5 is 25, times 5 is 125. Let's do one that's slightly different. How about 2 to the 5th power? Again, that's not 2 times 5, that's 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Now I want to make note of a few exponents that you'll often see. In this first example, we had the exponent of a 2, and we often refer to that as squared, a squared number. Okay, or you can say that's the power of 2. So 3 to the power of 2. Or 3 to the 2nd power. So I'm just giving you some different options for saying this, okay? The same thing when you have an exponent that is a 3. Instead of squared, we often say cubed, okay? 2 cubed, or 2 to the power of 3, or 2 to the 3rd power. In this case, we would say 5th power, or power of 5. There's, we don't really have a special name. Usually when the exponent is a 2 or a 3, those are the more common exponents that you're going to see. And so they have special names. Now there's a few other things I want to mention regarding exponents. Sometimes you'll see an exponent of 1. So if we have 5 to the first power, remember that exponent tells you how many times you're going to see the base number in a multiplication problem. So we're only going to see it once. So that would be the expanded notation. You're only going to see it one time. The standard would be 5. Also, you might come across an exponent that is a 0. So let's say we have 4 to the 0 power. Now later on in the next course, Math Trans 3, you'll visit or you'll learn about laws of exponents. So for now, the answer is just going to be 1. So anytime you have 4 to the 0 power, your answer is going to be 1. And we'll go over that in the future when we talk about laws of exponents. There's one other kind of exponent that I just want to briefly introduce, and that's when we have a negative exponent. So say we have, and this is in reference to scientific notation. And again, we'll do scientific notation at a later time. But let me just give you an example of what that might look like. And you might already know this, so you know it might be familiar when I write it down here. So let's say I have 2.5 times 10 to the negative 3. What that means is we're going to move the decimal to the left 3 places. So we're going to have 0.00225. No, the decimal point's here. Okay. So originally it was here. We moved it over 1, 2, 3, and that's what that means when you see a negative exponent. You're going to the left. That number is going to be a decimal or a fraction. But again, we're not going to focus on this right now. This will come at a later time. The last thing I want to mention regarding exponents is when the base is a power of 10. So, for instance, if we have 10 to the, let's say, second power, we know that's going to be 10 times 10, or 100. Well, let's see what happens when we cube it. We get 10 times 10 times 10. Well, we know this is 100. 100 times 10 will give us 1,000. And let's go ahead and try 10 to the 4th. And hopefully you're seeing a pattern at this point. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. Okay, so basically this exponent, when the base is 10, means the exponent is telling you how many zeros you're going to have with the number 1. Okay. Anyway, you'll get more practice with that. The last thing I want to cover is the inverse of taking exponents. All right. So earlier we had something like 3 squared. Okay, and that was 3 times 3, that gave us 9. Okay, we were squaring 3. Now, the inverse of squaring is taking the square root, and we might see something like this. So the square root of 9. And what we're looking for is the base. So, for instance, in this case, the base, in 3 squared, the base is 3, okay? Because 3 times 3 is 9. So in the square root of 9, the base, or the square root of 9, will be 3, because 3 times 3 is 9. Let's do another. The square root of 25. And you want to think of it this way. What number times itself will equal 25? Well, 5, because 5 times 5 is 25. Now notice there's no number written in this position, okay? And that's okay. When you're squaring and there's no number, you can assume it's a square root. But sometimes you're going to see a little number in that little left corner, something like this. So this number here is called the index. And that's going to tell you how many times, or it's going to, you're going to try to find the base of the number that when you multiply it this many times, you're going to get this number. Okay, so we're looking for a base that's the same, a number that's the same, that when you multiply it 3 times, you're going to get 8. And so your answer is going to be 2, because 2 times 2 is 4, times 2 is 8. So the answer would just be 2. You wouldn't necessarily write it out as 2 times 2 times 2. This is just kind of proving that your answer is 2. Whoops, this should be a 3. Let's do one more like that. Let's go 64. Okay, so again, we're looking for a number or a base that when we multiply it 3 times, we're going to get 64. Now, if you guess 4, you're correct. And to check that, 4 times 4 is 16. 16 times 4 is 64. Now, these are probably the square root and the cube root are probably the most common that you're going to see. There are others that you might come across, and I'll just do one. Say we have the 4th root of 16. And it's going to be a small number because notice, even though like in this one here, 64 is a large number, because we're multiplying the base 3 times, the answer has to be a relatively small number. So again, this is going to be a small number. So we're thinking of a number that when we multiply it 4 times, we're going to get 16. The answer is going to be 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So that would be the answer.